You lived an entire life before you turned 3. You were born. You opened your eyes for the very first time. You heard your mother's voice. You tasted food. You took your first steps. You said your first word. And you remember none of it, not one single moment. Most people assume the reason is obvious. Your brain just wasn't ready yet. You were too young. But that's not quite right, and the real answer is far stranger than you'd guess. Because your baby brain wasn't failing to record your life. It was recording everything. The memories were there. Something destroyed them. In 1905, Sigmund Freud became the first person to give this a name. He called it infantile amnesia. And here's the thing, babies absolutely can form memories. We know that for a fact. Back in the 1980, the psychologist Carolyn Rovi Collier at Rutgers ran a beautifully simple experiment. She tied a ribbon from a baby's ankle to a mobile hanging over the crib. The babies quickly figured out that kicking made the mobile dance, and they loved it. When she brought the same babies back days later, they remembered. They started kicking right away. 2-month-olds could hold onto that memory for a couple of days. 6-month-olds held it for weeks. So infant brains can learn. They can store information. They can recall it. But those memories don't survive. By adulthood, every last trace is gone. And for decades, scientists couldn't fully explain why. The first part of the answer is structural. Deep in your brain sits a small curved structure called the hippocampus, and it's the engine of memory. It's what takes a lived experience, a birthday, a conversation, a walk in the rain, and encodes it as an episode you can replay later in your mind. In an adult, the hippocampus works hand in hand with the prefrontal cortex to tag, store, and retrieve those episodes. But in an infant, this whole system is barely built. The connections between the hippocampus and the cortex are still under construction. A key region called the dentate gyrus, which acts like a gateway for new memories, isn't fully wired until somewhere between the ages of 2 and 4. So your infant brain could form short-term memories. It just couldn't move them into long-term storage the way an adult brain can. But that's only half the story. And honestly, what comes next is even stranger. In 2014, 2 neuroscientists in Toronto found something that changed how we think about infant memory entirely. Sheena Jocelyn and Paul Franklin at the Hospital for Sick Children had a hypothesis that sounded almost backwards. What if the very process that builds your brain is also what erases your memories? Here's what they meant. In your first years of life, your hippocampus is pumping out new neurons at an astonishing rate. This is called neurogenesis, and it's essential. Those new cells wire up the circuits you'll rely on for the rest of your life. But Jocelyn and Franklin suspected there was a price. Every time a new neuron muscles its way into an existing circuit, it disrupts the connections that were already there, the connections holding your memories. To test it, they turned to mice. When they artificially ramped up neurogenesis in adult mice, those mice began forgetting things they'd already learned. And when they slowed neurogenesis down in infant mice, those infants held onto their memories longer than they normally would. The results, published in the journal Science, pointed to a deeply counterintuitive conclusion. Your baby brain wasn't too weak to keep memories. It was too busy growing. The same explosion of new neurons that built your mind also overwrote the memories stored inside it. Your earliest experiences weren't lost because they were never saved. They were lost because your brain kept building new rooms and knocking down the old walls to do it. And there's another layer to this, maybe the strangest one of all. To form what scientists call autobiographical memory, the kind where you are the main character of an experience you can replay in your head, you need something most of us take for granted. You need a sense of self. You need to understand that you exist as a person, separate from the world, and that things are happening to you. In the late 1990s, The developmental psychologists Mark Howe and Mary Courage argued this was the missing piece. Before roughly 18 to 24 months, infants don't recognize themselves as distinct individuals. The classic test is simple. Put a dot of rouge on a baby's nose and sit them in front of a mirror. Before about 18 months, babies treat the reflection like another child. They don't reach for the mark on their own face. After 18 months, they do. They understand that the person in the mirror is them. And that moment, the birth of self-recognition, lines up closely with the earliest age at which autobiographical memories can form. In other words, part of why you can't remember being a baby is that there wasn't really a you yet, not in the way you experience yourself now. There was no narrator in your head packaging events into a story that belonged to someone called you, which raises an uncomfortable question. If you had no continuous sense of self, and the brain that held your earliest experiences physically rewired itself beyond recognition, is the baby in your old photos actually you? Or is it someone else entirely, someone who lived in the same body, but whose mind was quietly taken apart and rebuilt, neuron by neuron, into the person you became? There's one more piece: language. The developmental psychologist Catherine Nelson spent years studying how children form lasting memories, and her conclusion was that language doesn't just describe our memories, it structures them. Before you could speak, your experiences were stored as raw sensory impressions. Sounds, textures, emotions, flashes of light. But with no words to organize them, those impressions had nothing to attach to. Once children begin talking, and especially once they start having conversations with adults about the past, remember when we went to the park, their ability to form lasting memories improves dramatically. Language gives memory a skeleton. Without it, experiences are like water with no container. They exist in the moment and then they are gone. And this isn't just theory. The psychologist Kai Wang at Cornell found that the age of your earliest memory actually shifts depending on the culture you grow up in. In Western cultures, where parents constantly narrate a child's life, asking questions, telling stories, building personal histories, earliest memories tend to begin around age 3.5. Among the Maori of New Zealand, whose oral tradition places enormous weight on personal history and storytelling, first memories can reach all the way back to around 2.5. And in some East Asian cultures, where early childhood stories focus less on the individual, first memories tend to start closer to 4, or even later. The culture you're raised in literally shapes how far back your memory can reach. So here's what actually happened to your earliest years. Your hippocampus wasn't ready to build long-term memories. And as it started to, the flood of new neurons tore through the very circuits that held them. You had no concept of self to anchor experiences to. And you had no language to give those experiences a structure that could last. It wasn't one thing. It was all of it at once. Every human being who has ever lived went through this. Every person you've ever met carries a black hole where the first years of their life should be. And the reason isn't that your brain was too simple. It's that your brain was doing something far more important than remembering. It was becoming you, and that required, quite literally, destroying the person who came before.